Baumann.
My name King Milani, and this is Lab 11 on it. Detectors.
Silicon detector can barely detect the LED above the noise, whereas the photomultiplier tube is much more sensitive to photons entering it than the silicon detector. We can still see the PMT signal because the PMT literally multiplies the photon count, whereas the silicon detector cannot detect low photon levels. Using the cursor, we calculated the signal-to-noise ratio of the PMT to be about 43.77. We used the single sequence function on the oscilloscope and then hit run, and we were able to get this for the silicon detector, and we used the cursor to measure the peak-to-peak voltage. So we calculated a max voltage of 290 millivolts and a max current of 2.9 microamps. We repeated the same procedure for the photodiode, and we got a max voltage of 88.8 millivolts and a max current of 0.888 microamps. We repeated the procedure for the photoconductor detector, and we got max voltage of 388 millivolts and a max current of 38.8 microamps. We then repeated the photoconductor with the 50 ohm resistor in series. We couldn't find the peak-to-peak for the photodiode with the 50 ohm resistor.
Actually,
which does not show up.
down, you get them.
Okay.
So for experiments 2, these are our respective max voltages and max currents for our various sources, and we were unable to determine the max voltage for the photodiode when it was connected to the 50 ohm resistance.
Response. To calibrate the spherometer, we simply measure the reference as the optical table, and we get 5.13 millimeters. We then measure each surface of the germanium lens with the spherometer, and that gives us the sag.
From this, we can tell that the soldering iron and the image of the soldering iron have the same temperature.
Yes, the pyroelectric detector can detect other bodies in the lab. Here's an example.
That's exactly
Not really getting that. Okay, there we go.
That's a spicy.
You're a supportive parent.
For the pyroelectric detector part, we set up a 2F system, and then we changed the frequency of the chopper to see how the peak-to-peak voltage changes.
Here's our data for the frequency response of the pyroelectric detector. As you can see, as chopper speed increases, the peak-to-peak voltage decreases, which means it has a poorer frequency response as the chopper speed increases. This means that the pyroelectric detector is not able to respond fast enough to the heat incident on the detector.